In this video, I'm going to show you how to balance a chemical equation. So the way I start these problems is by finding an element that occurs in the least number of molecules on both the reactant and the product side. So to show you what I mean, I wouldn't start with oxygen because it occurs in both this molecule and this molecule on the reactant side and also on both these molecules on the product side. Whereas carbon, on the other hand, occurs in just this one molecule on the reactant side and this one molecule on the product side. And the same thing with hydrogen. So to keep track, I'm just going to write this underneath here. We have, for carbons on the left-hand side, we're going to count them. And there's only one carbon on the reactant side. And I guess I'll draw this arrow to show that this is the number of carbons on the reactant side. And on the product side, we also have just one, so that's already balanced. And I'll go on to hydrogen next, because hydrogen also is only in this one molecule here and this one molecule over there. So we have 3 plus 1, so there's 4 hydrogens on the reactant side. And on the right-hand side, we have just 2 from this one water molecule. So to bring this up to 4, we can add this coefficient of 2. So now we have 2 water molecules, each with 2 hydrogens each, which totals up to 4. So now that is balanced. So now we can go on to oxygen, which is where this problem gets a little bit harder. So on the left-hand side, the reactant side, we have 3 oxygens. We have 1 from this molecule and 2 from here. So we have 3 on the reactant side. And on the product side, we have 2 from CO2 and also 2 from water, because we have these 2 water molecules each with 1 oxygen each. So we have 4 on the right-hand side. So obviously that's not balanced. So what we want to do is we can either decrease the number of oxygens on the right by 1, or we can increase the number of oxygens on the left by 1 so that they're equal. So if we were to try to decrease by 1 on the right side, you could see that that'd be very hard to do because if, say, we decrease this from 2 to 1, then that undoes what we just did here with the hydrogen, and then we would have to go through and change everything again. And the same thing with over here. If we were to change this to like 1/2 or something like that, that would change the number of carbons, which we just did. So that would basically undo the work we did so far. So we know that we're going to have to do something on this the left-hand side, and same thing over here. If we add a 2 here, that changes the number of carbons and the number of hydrogens, undoing the balance. But with this one molecule here, because there's only an oxygen in it, we can put any number in front of here and it doesn't undo the balance of carbons and hydrogens. So we know that we're going to have to do something here. So what we want to have total is 4 oxygens on the left, and we already have 1 here. So we know that we want to get 3 oxygens out of this O2. So we have a problem, because if we put a 2 here, I guess I'll write this in. If I put a 2 here, then on the left-hand side we'll have 5 oxygens, because we'll have 2 times 2 each for this oxygen, plus the 1 here. So we'll have 5, and then we would have to then go back to the right-hand side and then increase that, and then that changes all our carbons and hydrogens again, and it just becomes a mess. So we have to do something else. And what we have to do is actually use fractions, and I'll show you an easier way to think about this. So this subscript 2, it's kind of makes it a little bit harder to think about. So what you can do is think about this O2 as the same thing, more or less, is equal to having 2 oxygens. So just like in math, if you have like something like 2x and you want it to you want to have 3 of that, what you would have to do is multiply by 3 over 2, and then you could cancel out both of these 2's, and that would be equal to 3x. So you can rewind that if that doesn't make any sense to you, but it's the same thing here with the O2 or the 2O. What we have to do is multiply by 3 over 2, and then that would give us exactly 3 oxygens total. So then, so this, the way it's written, it looks kind of complicated, but really all that means is, I guess I'll do it one more time to help you. So this is essentially the same thing as 3 halves times 2 oxygens, because each oxygen has a subscript 2, so there's 2 of them. And then these 2's cancel, and you end up with 3 oxygens. Okay? So we'd have 3 oxygens plus this 1 oxygen here, and then we have finally 4 on the left-hand side and 4 on the right-hand side. And everything is balanced. But for these chemical equations, it's not good to leave these fractions here. So what you have to do is multiply everything through by the number you have in the denominator to get rid of that. So what we would have is we would multiply this entire equation by 2. So we would end up with a 2 coefficient here. 3 halves times 2 would be equal to 3. So I'm just going to scratch that out. That's equal to 3 now. And then 2. And then we would have 2 times 2. And this would become 4. So that's kind of messy, but I think you can see what it is. So that would be the final answer. It would be 2 times CH3OH plus 3O2 goes to 2CO2 and 4H2O. And that is the final answer for that problem.